All right, let's go ahead and get started. Today we're going to do section 2.3. 2.3 is actually module 1, lesson 3. So we have a lot of definitions today. We have the universal set, the Venn diagram, complement of a set, intersection of a set, and union of sets. So our universal set, that is just basically what we're going to be looking at for that specific problem. It contains all the elements that are being considered in a given discussion or problem. A Venn diagram, at this point in your life, you should have all seen a Venn diagram with the circles intersecting, and you could have 2 circles, you could have 3, 4. So a Venn diagram is just a visual relationship among sets. And then these 3 down here, we have the complement of a set, intersection of a set, and then the union. So a complement is going to be the elements that are not in that specific set that they're asking for. So if we have the complement of A, it is going to be what is not in that set. What is not in set A? So complement is represented with that little tick mark. So the complement of a set, and let me just highlight this. So you will use that little tick mark after the set, and it is going to be what is not in that set. We have the intersection of sets, which is the set of elements common to both sets. So if we were looking at a Venn diagram, the intersection would be this middle piece right here where those 2 sets intersect. And intersection of sets is represented with this upside down U symbol, and it is also represented with the word and, because if we're looking at sets A and B, it's this middle part where the elements are in A and B. And then the union of sets, if we were to draw a Venn diagram, the union would be everything in both of those sets. It is the set of elements that are members of each individual set or both sets. And then the union is represented with the U. So the union of A and B is going to be also represented with the word or, because the element can be in A or B. And then we have a formula for the cardinal number of the union of 2 finite sets. So we're going to go back to this formula at the very end. So it says on exercise 1, use the roster method to write each of the following sets. So remember, anytime you see that tick mark, it is going to be the complement of a set. So the complement of A would be what is not in set A, but is in universal set. So the way that that would look is, if we were looking at the complement of W, the easiest way that we can find what is not in set W is to just mark through those elements that are in our original set. So W has A, B, F, and G. I'm going to mark them out from our universal set, and we are left with C, D, and E. Okay, same thing for the complement of X. The complement of X has the letters C, D, and E. We can mark those out, and we're left with A, B, F, and G. Okay, the complement of Y, so we'll do the same thing. I'm going to mark out A and G, and we are left with B, C, D, E, and F. And then the last one is Z. So Z has A, B, C, D, E, and F. Put those out. We are left with G. Okay. Number 2, find each of the following sets. So here we are looking at the intersection and the union, and then down at the bottom we have a couple with the complement. So remember, intersection is represented with the upside down U, and it is the elements common to both sets. And so if we had a Venn diagram, intersection would be this middle part. And then union is represented with the U, and it is going to be the elements listed from both sets. So all elements. And so if we were to use a Venn diagram, we would shade in both sets. Okay. So on letter A, we are looking at the intersection of M and P. So the intersection of M and P is going to be the elements that are in both of these two sets. So M has 1, 3, 5, 7. And P has 2, 3, 4, 5, and 6. So we're looking at this and this. So 3, they both have 3 in them. They both have 5, and it looks like that's it. So the intersection of M and P would be 3 and 5. Okay. The union, letter B is the union of N and P. So N and P. N has 1, 2, 3, and then P has 2, 3, 4, 5, 6. So remember the union, we are going to list the elements from both sets. So we've got 1, 2, 3 from N, and then P has 2 and 3 as well. We're not going to list those twice. We're only going to list them once, so we can list the rest of them 4, 5, and 6. Okay. Letter C is the complement of N and then intersected with P. So we have to find the complement of N first. The complement of N is what is not in that set. So if N has the numbers 1, 2, and 3, we're left with 4, 5, 6, 7. So the complement of N is 4, 5, 6, 7. And we can intersect that with P, which is 2, 3, 4, 5, 6. So the elements that are common to both, we have 4, 5, 6. Okay. And then on the last one, we have the union of M and the complement of C. So remember, we have to find this first. I'm sorry, the complement of P. The complement of P is what is not in that set. P has 2, 3, 4, 5, and 6. So we are left with the complement of P being 1 and 7. And we can union that with M. So M union 7. M has 1, 3, 5, 7. So that is going to be our answer. 1, 3, 5, and 7. Because the complement of P has 1 and 7, and this one already has it in there. So 1, 3, 5, 7. Alrighty. Number 3. Use the Venn diagram to represent each set in roster form. So they actually give us the Venn diagram, and they want us to find the intersection and union and list all the elements. So intersection is the upside down U. So that is going to be the elements that are in the intersection piece, which is just 3 and 7. Let me actually draw it right here. Okay, the union of A and B would be both sets. Okay, so everything from the circles, we've got 1, 4, 3, 7, 2, 5, and 6. So most of the time, Pearson is going to ask you to put these in order. So let's go ahead and put them in order. 4, 5, 6, 7. Okay. C, we are going to find the union of A and B first, and then find the complement. So the union of A and B is everything inside the circles. If we take the complement of that, it would be what is not in the circle. So everything that is left in the universal set. So up here we have 8 and 9 that is left from the universal set. D, we have the intersection of A and B, and we want the complement of that. So our intersection is this piece right here. If we take the complement of that, it would be everything except that intersection piece. So it would be 1, 4, 2, 5, 6, 8, and 9. So everything except 3 and 7. So 1, 2, 4, 5, 6, 8, and 9.
Hi, Christy. Hi, Christy.
Hey, how are y'all doing?
We're all alive. Last time I checked.
Uh-huh.
Doing good. Thank you. Good, good.
All right, number 4, it says to use the Venn diagram to determine each cardinality. So cardinality is the number of elements in a set. So the cardinal number equals number of elements in set. And it is represented with the n, the little n, and then parentheses. So the cardinal number of the union of A and B, so A and B, remember, is everything in circles. the cardinal number would be how many elements we have. So we have 1, 2, 3, 4, 5, 6. The intersection of A and B is that middle piece where they intersect. There's just one element, the triangle. C is the complement of A. So A is everything inside of our circle. So we want everything outside, which would be 1, 2, 3, 4, 5 elements. Okay, and then our last problem says to use the formula for the cardinal number of the union of two sets. So that formula is going to be the cardinal number of the union of A and B. And we are going to take the number of elements in A, add them to the number of elements in B, and then subtract the number of elements in that intersection. So A says set A contains 17 elements, set B contains 20 elements, and 6 elements are common to both. How many elements are in the union of A and B? So if we were to use that formula up there, we would take the elements that are in A, so that would be 17, add them to the elements in B, which would be 20, and then subtract the elements that are common to both, which would be 6. And we get 31 elements. And then we'll do the same thing on B. B says set A contains 8 letters and 9 numbers. So we've got 17 total elements. Set B contains 7 letters and 10 numbers, so 17 again. And then there are 4 letters and 3 numbers common to both, which is 7 elements. So if we use our formula, we have 17 plus 17 minus 7 gives us 27 elements. And that is all that we are going to look at today.